Okay, g'day students and welcome to our lesson on plotting linear graphs. So if I just want to have a look here at these words, plotting means to put some points onto a Cartesian plane. Linear means a straight line and a graph is, a linear means straight, and a graph is that line on a Cartesian plane. If we are going to look at our learning goal for today, we want you to be able to plot the relationship between two variables on a Cartesian plane. So the two variables we've been talking about so far are the x and the y variable. Now your key ideas. If a relationship, the relationship between two variables can be graphed on a Cartesian plane. And if the plotted points form a straight line, then it is a linear relationship. Now remember, linear just means straight. So that's an important one to recognise today. Now, creating a table of values helps work out the coordinates that can be plotted. Now, a linear graph has features such as a gradient, an x-intercept and a y-intercept. Now, the gradient describes the slope of the graph. The x-intercept is where the graph crosses the axis. The x-axis, the y-intercept is where the graph crosses the y-axis. So we might just pull up our PhET simulation and have a little bit of a look at this, and we'll talk through the first one. So just look at the slope at the moment. So let's just make this a straight line, and I'm just going to go to that one there. So this one, if I have a look at this line passes through the origin. For every 2 we go across, we go up 2. So we say that this slope is 1 because 2 divided by 2 is 1. Now the point at which this line crosses the x-axis is called the x-intercept. So if I change that, you can see now that it's crossing the x-axis at, what do we say, that's 0, -1, -2. So the x-coordinate, or our x-intercept, is -2. Now if I'm looking at my y-intercept, that's +1, that's +2, so I'm estimating that to be about 1 1/3. So my x-intercept is 0 on the x-axis, -2 on the x-axis and 0 on the y-axis, and my y-intercept has got to be a 0 on the x-axis, and then about 1.3 or 1 1/3 for the y-axis. So some important concepts to note with the Cartesian plane. So revising this one from previous lessons, our Cartesian plane consists of 4 quadrants. If I look at the top right hand corner, I work anti-clockwise, so that's going that direction. Quadrant 1 is positive x and positive y. Quadrant 2 is negative x, positive y. Quadrant 3 is negative x and a negative y. And quadrant 4 is a positive x and a negative y. And the origin is the point 0, 0. That's where it all starts. Now looking on the right hand side, as I said before, the x-intercept is where this graph crosses the x-axis. So we can refer to this line as a graph and the set of axes as a Cartesian plane. Now the y-intercept is up here. That's where this line crosses the y-axis. So we have our x and y-intercept. We have our origin and our 4 quadrants. Now let's start plotting a line to note a relationship. And you're going to either have to get a lot of these photocopied or do it digitally or something like that, because we're going to be constructing a lot of graphs in this lesson. So we've got a Cartesian plane and we want to use this table of values to plot the graph of the relationship between x and y. So we have a look at our x and our y variables and we plot them together as one set of coordinates, and we can call them polar coordinates, and from there we get words like extrapolate, but that's another day's lesson. So our first one is what? -3 on the x-axis and 6 on the y-axis. So the point where they intersect has got to be there. Now my next set of coordinates, -2 on the x-axis, and then 4 on the y-axis. So the point at which they intersect is there. And let's look at our next one, -1 and 2. So -1 and 2. Now, generally have 3 dots to indicate that it's got to be a straight line. Otherwise, it could curve in the middle, for example. So generally a minimum of 3 dots to prove that it's a straight line. So let's now have a look and just continue to prove that this is a straight line. So now we're going 0, 0, so we're passing through the origin, and then we've got 1 on the x-axis, which is this one, but now we're going down to -2 on the y-axis. Then we've got 2 on the x-axis and -4 on the y-axis, so 2 and -4 is there, and then we go 3 and -6, so 3 and then -6. You can see that I'm reading x and y all at the same time. Now we generally need a ruler to draw a straight line for this, but because I'm on the computer, I'm just going to do it this way. And just note that, ooh, this is not quite nice, but it's going to do a job for the moment. Yep, that's worked nicely. So you can see that I've plotted in my coordinates, and then I have drawn a line from point to point. This line has said it's starting at this coordinate here, which is this one, and we're finishing here, which is this one. And it's not going any further from the moment. So we can also note the relationship between the x and the y variable. Now, if I said y equals x, what's happening to the x variable to get to the y variable? So I know that 3 times 2 is 6, but in this case it's got to be multiplied by -2, hasn't it? So my relationship is y equals x times -2. Now I just rewrite that a little bit better and say that y equals -2x. I just continue to look through this. 3 times -2 is -6. -1 times -2, yeah, that's +2. So that confirms my relationship. Let's have a look at this one. Now we have a linear function. And from that linear function, I can get a list of coordinates. So what I need to do is just say, well, y equals, and we'll generally have to do a bunch of calculations on the side down here and just go, well, y equals 2x take 1. Now, I've got all my x values, so I'm going from, what, -3 to +3. So, so we said x is bigger than and equal to -3, but it's smaller than and equal to 3. And so we write this sort of relationship, or the conditions, I suppose, for the line, and then we just fill in. So 2 times -3 take 1. Well, 2 times -3 is -6, take 1 is -7. Y equals 2 times, now it's -2 because that's our next one. 2 times -2 is -4, take 1 is -5. The next one is y equals 2 times -1, take 1. Well, 2 times -1 is -2, take 1 is -3. Y equals 2 times 0, which is 0, take 1, which is -1. Now, you can see that we have a common difference. So it's going up by 2 each time. So we'll just finish this set of coordinates. So y equals 2 times 1, take 1. Well, that's got to be 1. Y equals 2 times 2, take 1. 2 2s are 4, take 1 is 3. And our final one for this condition here, 2 times 3 is 6, take 1, well, that's got to be 5. And you can see that this pattern continues. Once we've done that, we just plot our coordinates on a Cartesian plane. So, what can we notice? That this is our x value here. Where are we? So, our x value and our y value. So we're just plotting all of these. Or I could just put a read from this table over here. So I could just put them all into a table as well, which is generally what I do. Okay, so let's go -3 on the x and then -7. So -3, -7. So here's -7, here's -3. So the point at where they intersect is going to be there. And then the next one, we've got -2 and -5. So -2, -5, got to be there. Next one is -1, -3, there. 0 and -1, so 0 on the x-axis and -1 on the y-axis. Then 1, 1, then 2, 3, so 2, 3, and 3, 5, so that's got to be there. Then we just get our straight line and connect the dots. It's not being very nice for me. And we generally also just write the function on the lines. So we can say that y equals, what did we say it was? 2x minus 1. And that's my linear function turned into a linear graph. So you can see that this is the function and over here is my graph. Now, finally, we just want to locate the x and the y intercept. Now, remember my rule is where the line intercepts the x-axis is the x-intercept. So we say x-intercept and y-intercept. So let's find the x-axis first, and this is the point at which the line crosses the x-axis, so that should be about a half. So we say the x-intercept is a half because it's crossing the line there, and our y-intercept, it's between -1 and -2. So that might be my dodgy diagram. It should be closer to -1, I think. Yeah. So my y-intercept equals -1. So you're going to have to be a little bit more precise than I can be on the computer here. Okay, what I'd like you to do now, folks, is you'll need to prepare yourself some Cartesian planes. Otherwise, you'll just have to draw a lot up in your book. And have a go at the mastery questions, please.